And then I want to talk some about multi-frame operations. So let's say you're a customer, you've got 2 or 3 SCADA systems, you normally use them independently, and you're like, boy, sometimes it would be nice if I could take my 3 12-channel systems and make it look like one big 36-channel system to a single computer running SimCenter Test Lab. That is possible in the SCADAS Lab and SCADAS Mobile family by using a main secondary interface. One thing to be very clear, the SCADAS Lab comes with this built in, but a SCADAS Mobile or a SCADAS Recorder, it's an option. It's something you do have to order from the factory. You can get it after a system is built. It's an easy module to plug in later on. But then using these fiber optic cables, we can plug together multiple systems and they will appear to the test lab computer like one giant front end where the backplane is all, think of it as connected through the fiber optic, extremely low latency, sample to sample synchronization works very robustly, give even very accurate phase to very high channel counts and high sample rates. There is a limit to the standard fiber optic cable length. Now even 250 meters, most people are like, okay, that's plenty. But we have had some customers saying, hey, I want to go even farther. So there's an option where we can go up to like 3 kilometers of distance between the SCADA frames themselves. So you can get them really spread out in some large field test or something like that if need be. I mentioned briefly earlier that typically we're limited to the maximum bandwidth for any single front end, any single computer based on the actual front end itself. So the SCADAS Lab, like is shown down here, is 19 megasamples maximum between one computer and one front end. These SCADAS Mobiles are a maximum of 14 megasamples. But what if somebody said, hey, I really want to have, not 190 channels at 100 kilohertz, but 190 channels at 200 kilohertz, or maybe 400 channels at 50 kilohertz, or anything that's beyond 14 or 19 megasamples. It's not well known to a lot of our customer base today, but in those very high bandwidth, high channel count scenarios, it is also possible to configure a setup where you have multiple front ends plugged into a high-speed network switch. I'll be careful, not just any network switch, but specific hardware we can help specify. Then a single computer plugged into that same switch. And through the front end configuration tool, we can then say we're going to use a multi-network approach, and those front ends are all time synchronized, sample synchronized, and look like one big front end, essentially per se, to the test lab computer, and we can then measure them that way. So this gives me higher bandwidth capabilities than the main secondary approach that I talked about previously. In this case, using the fiber optic connection, I'm still limited to the single frame connection speed of 19 megasamples or 14 megasamples. Using this network switch connection approach, I can actually go higher than that, where I still have a single computer, but then I can get into like 38 or 40 or even 50 megasamples per second, depending on the architecture and connection. So that's how it works for SCADAS Lab and SCADAS Mobile. SCADAS XS, though, a little bit unfortunately, is a different platform, and so I cannot combine SCADAS XS in a single large main secondary or distributed system. XS and Mobile or XS and Lab doesn't work, but XS units themselves can be put into a specialized network switch that we sell, where I can take up to 7 12-channel units, give me 84 channels of capability as one large front end. And in this case, we do it a little differently with the IEEE Precision Time Protocol that does the synchronization. Now, to be clear, this is a very specialized network switch. This doesn't work for just any switch you could go buy off the shelf because it needs power over Ethernet. That's pretty easy to find nowadays, but the IEEE Precision Time Protocol is pretty unique in the network switch, and it has to be configured specifically to work with the SCADAS XS. With that being said, with one of these specialized switches we sell, I can plug in this TAN cable is showing like the connection to the host computer, and then the other 7 ports are available to plug in multiple network XS units, and then again I can get a higher channel count for a single measurement client, all with running SimCenter Test Lab. Oh, I knew there was one thing I was going to say. Typically, XS units are not delivered with this network capability. It's an option, but even if you purchased 12-channel XS that doesn't have that, it can be added on after the fact. So you can come to us and say, hey, I want to upgrade some of my XS existing units to the network version. Only works for the 12-channel, not the 6, but it's possible for the 12-channel units. Another thing I wanted to at least mention and have one slide in here because it's probably a fringe use case, but I found a few customers were surprised that we offered this. If you're familiar already with any type of network communication protocols normally used in manufacturing facilities, Modbus, EtherCAT, there's a few other ones out there. We do have a very specialized module available for Scadis Lab and Scadis Mobile called the ESO64 EtherCAT module. And what this allows us to do is plug this card into any existing lab or mobile frame you may have, and then program it with up to 64 channels of output that is broadcast on the EtherCAT network. Now this requires an EtherCAT main or master unit, like typically that's a PLC, say in like a test cell scenario or like in a manufacturing scenario. But our Scadis mobile and Scadis lab systems can hang on this EtherCAT network as a secondary unit and broadcast data with very good synchronization accuracy to make that information available to the other EtherCAT devices that can either be used for control, measurement, feedback, etc. The other interesting thing is that this EtherCAT module operates independently in the frame. You can still be plugged into it and be making measurements with test lab intermittently if you wanted. So once that's programmed and turned on, it just broadcasts in this EtherCAT fashion the signal condition values coming into the measurement channels themselves. One other caveat though is that not all of the input cards support this real-time, the quote-unquote real-time scenario. They have to have the RT at the end. So like in this case, this RV4 TACO card, the RT means it's the real-time version that works for EtherCAT. If you have a VB83, a Victor Boy 83, the -RT version works for this EtherCAT scenario. It has to have the RT in the end of your input modules. So one small thing to keep in mind. But